Imagine this. You're standing on the edge of a vast crimson desert that stretches endlessly to the horizon, where the thin whispering air carries secrets of a world that has been silent for billions of years. The sun hangs low in the sky, casting elongated shadows over jagged rocks that have withstood the relentless onslaught of cosmic forces across eons. Suddenly, your gaze locks onto one seemingly unassuming stone, a slab of reddish mudstone, intricately veined like the dried bed of an ancient river, adorned with peculiar patterns, tiny dark flecks reminiscent of scattered poppy seeds, encircled by faint rings that mimic the distinctive spots on a leopard's coat. It's just a rock, you might initially think, nothing more than a piece of the Martian landscape. But what if this rock holds the faint fossilized echo of life from another world entirely? What if embedded in its silent grooves and textures lies the undeniable proof that we are not alone in the vast expanse of the universe? This isn't a scene pulled from the pages of a thrilling science fiction epic or a blockbuster movie. This is the reality of Mars, as unveiled by NASA's Perseverance rover on July 21st, 2024, during its ongoing exploration of the Red Planet. And as of September 10th, 2025, just a few short weeks ago, NASA made a groundbreaking announcement that this rock, affectionately nicknamed Chayava Falls, harbors what could very well be the most compelling evidence yet of ancient microbial life on Mars. A sample meticulously drilled from it, carefully sealed away under the designation Sapphire Canyon, is brimming with potential biosignatures, intricate organic molecules, minerals rich in energy sources, and surface textures that practically scream life to anyone familiar with Earth's own geological records from ancient times. It's not definitive proof by any means. No one's popping champagne corks or declaring victory just yet, but it's the closest we've ever come to such a monumental revelation, the kind of discovery that makes your heart race with excitement, that forces you to pause in your daily routine and wonder deeply, are we truly on the cusp of answering humanity's oldest and most profound question about our existence? Hold on to that sense of wonder and anticipation, because this story isn't merely about a single rock discovered on a distant world. It's about a planet that once teemed with flowing rivers and expansive lakes, a robotic rover that serves as our tireless and intrepid explorer in the harsh Martian environment, and a global quest involving scientists from around the world that's pushing the very boundaries of what we believe is possible in space exploration. It's a narrative filled with false dawns that raised hopes only to dash them, hard-won truths that have reshaped our understanding about the sheer thrill of the chase across an astonishing 225 million kilometers of empty void between Earth and Mars. And ultimately, it's about us, you and me, everyday people, staring up into the stars at night, hungry for a sense of connection to something greater than ourselves. If this narrative has hooked you from the start, hit that like button right now. It tells the algorithm and perhaps the universe itself that stories like this truly matter and deserve to be shared widely. Drop a comment below. What would finding life on Mars mean to you personally? Would it change how you see your own life and place in the cosmos? Let's build this conversation together, one thought at a time. And if you're new here, subscribe for more immersive dives into the cosmos. We've got entire galaxies of wonders waiting to be explored ahead. But let's not rush headlong into the reveal without proper context. To truly grasp the immense gravity and significance of Chayava Falls, we have to journey back, not just to the events of last year, but all the way to the dawn of our collective obsession with the Red Planet, which has captivated astronomers, scientists, and dreamers for generations. Buckle up for the ride. This is a tale woven with threads of persistence against overwhelming odds, heartbreaking setbacks that tested resolve, and an unyielding curiosity that drives humanity forward into the unknown. Our story unfolds in the vast expanse of Jezero Crater, a 45-kilometer wide scar etched into Mars's northern hemisphere, formed by cataclysmic impacts from asteroids or comets eons ago in the planet's turbulent history. Picture it as it was 3.5 billion years back in time, not the barren, wind-swept dust bowl we observe today through telescopes and rover cameras, but a vibrant and life-sustaining oasis teeming with potential. A massive lake shimmered under a hazy, carbon dioxide-rich sky sky, nourished by rivers cascading down from the crater's rugged rim, carrying with them sediments abundant in clays, minerals, and organic compounds. The perfect nursery for life as we understand it from our earthly perspective. Scientists deliberately chose Jezero as the landing site for Perseverance precisely because of this rich geological history, which promises clues to Mars's watery past. It's akin to unearthing an ancient shoreline on Earth, where layered fossils whisper tales of creatures long extinct and ecosystems that once flourished. If microbial life ever stirred and took hold on Mars during its wetter epochs, this is precisely where we'd expect to find its ghostly remnants preserved in the rock record. Fast forward to Sol 1196. That's Martian Day 1196, corresponding to July 18th, 2024, in Earth time, when the sun rises and sets on our blue planet. Perseverance, that remarkable six-wheeled marvel, roughly the size of a small golf cart and equipped with cutting-edge technology, trundles methodically along the floor of Neretva Vallis, a now parched river valley that once spilled its waters into the heart of Jezero. Its high-resolution cameras, as sharp and discerning as a hawk's eye scanning for prey, spot something truly anomalous amid the monotonous terrain. A fractured outcrop of mudstone, partially buried in the fine regolith dust, striped with white veins that hint at long-vanished flows of mineral-rich water seeping through the ground. But it's the surface features that stop the mission team in their tracks, causing a stir in control rooms back on Earth. There, etched into the rock with intricate detail, are those eerie and unexplained patterns. Millimeter-sized dark spots clustered in irregular bands, rimmed by pale circles that add to the mystery. To the untrained eye, it might appear like a random Rorschach test imposed by the cosmos itself. To seasoned geologists and astrobiologists, however, it's nothing short of a siren call beckoning them to investigate further. Ken Farley, the esteemed project scientist for the Mars 2020 mission based at Caltech, recalls the electrifying moment in NASA's September 2025 press conference with vivid clarity. We knew immediately this was something special and out of the ordinary. On Earth, features like these, leopard spots as we came to call them, are unmistakable hallmarks of biological activity from ancient times. Microbes thriving in nutrient-rich sediments, feeding on available iron and sulfur compounds, leaving behind these telltale waste products as the surrounding mud gradually hardens into enduring stone over geological timescales. The team, monitoring every move from the bustling Jet Propulsion Laboratory in Pasadena, California, swiftly redirected the rover like a skilled bloodhound hot on a scent trail. Perseverance inched closer with deliberate precision, its sophisticated robotic arm extending outward like a surgeon's scalpel poised for a delicate operation. What followed was a meticulously orchestrated symphony of science, blending technology and human ingenuity in perfect harmony. The rover deployed its full arsenal of instruments. PIXL, a highly advanced pixelated X-ray spectrometer that maps elemental compositions right down to the individual grain level. Sherlock, a laser-wielding detective specifically designed to hunt for organic molecules and mineral signatures. And Watson, its reliable sidekick camera that captures ultraviolet fluorescence to reveal hidden details. The data streamed back across the immense gulf of space, byte by byte, painting a picture more tantalizing and evocative than any artist's imaginative rendering could ever hope to achieve. The spots themselves, they proved to be rich in iron, phosphorus, and sulfur, key elements that microbes on Earth absolutely adore and utilize for their metabolic processes. The rings around them, laced with rare minerals like vivianite and greigite, which are typically born from the decay of organic matter, from life breaking down and reintegrating into the Earth over time, and threading through it all like a common theme: organic compounds, those fundamental carbon-based chains that serve as life's essential Lego bricks, building blocks for everything from proteins to DNA. By July 23, 2024, Perseverance had successfully drilled a precise 6 millimeters into the heart of Chayava Falls, coring out a precious cylinder of mudstone material and sealing it securely in a sterile titanium tube designed to preserve its integrity. A selfie followed shortly after. Yes, the rover actually posed with its new prize in hand, the fresh borehole gleaming like a recent wound in the rock's surface, capturing the moment for posterity. That tube, officially labeled Sapphire Canyon, joined joined an impressive cache of 33 others by July 2025. Perseverance's growing haul now includes 13 sedimentary rocks, 8 igneous samples, and even a vial containing a Martian air sample, all carefully cached and awaiting a future ride home to Earth for detailed study. But back then, as the fine drill dust settled back onto the Martian surface, no one dared to whisper the word life too loudly. Excitement buzzed through the air like electricity, sure, but so did a healthy dose of caution born from past experiences. Mars, after all, has broken scientific hearts before, leading to dashed hopes and reevaluations. Pause here for a moment and take a deep breath. Can you feel that underlying tension building? It's the very pulse of discovery, the electric hum that vibrates between unbridled hope and rigorous skepticism, keeping scientists grounded. If you're feeling it too, smash that like button. It's the fuel that powers more stories like this one. And drop a comment. Have you ever chased a personal hunch that paid off big in unexpected ways? Share it with us. We're all explorers in this grand adventure together. To understand why Chayava Falls feels like such a monumental breakthrough in the field of astrobiology, we must confront and learn from the ghosts of Mars' exploration's storied past. Our hunt for life on the red planet isn't a recent endeavor. It's a sprawling saga that spans nearly 50 years, laced with remarkable triumphs that advanced technology, tantalizing teases that sparked worldwide excitement, and crushing letdowns that forced reevaluations of methods and assumptions. It's a powerful reminder that science isn't a straightforward sprint to the finish line. It's a grueling marathon through layers of doubt and uncertainty, where every step forward demands we revisit and reflect on the stumbles that came before. Rewind the clock to 1976, a pivotal year in space history. Humanity's first robotic ambassadors to Mars, NASA's Viking 1 and 2 landers, touched down on the planet's surface amid global fanfare and high expectations from the scientific community and public alike. These were no mere probes sent to take pictures. They were fully equipped laboratories on legs, complete with sophisticated ovens for heating samples, gas chromatographs for analyzing compositions, and a radical biological experiment known as the labeled release test. Imagine the setup: squirting a specially prepared nutrient broth, infused with radioactively tagged carbon compounds, directly onto Martian soil samples, and then watching closely for signs of metabolism. If any form of life stirred within the dirt, it would theoretically exhale those tagged gases, lighting up the detectors like fireflies dancing in the night sky. The results that came back? They sparked initial euphoria that quickly turned to agony and debate. Viking's soil samples burped out carbon dioxide almost immediately upon contact, as if invisible microbes were eagerly feasting on the provided nutrients. Headlines around the world screamed "Life on Mars" in bold letters, and Gilbert Levin, the brilliant designer of the test, was firmly convinced they had hit the jackpot, but the skeptics, ever vigilant, pounced on the data with critical eyes. Further tests, such as pyrolyzing the soil to break it down and sniffing for organic compounds, turned up absolutely zilch, no traces at all. The true culprit emerged: perchlorates, highly reactive salts embedded in the Martian dirt, which were capable of mimicking biological processes through purely chemical reactions alone. No life was needed. It was just a planetary prank played by inorganic chemistry. The Viking team spent decades locked in heated debates, but the consensus eventually settled on abiotic illusions as the explanation. Mars was deemed sterile, at least on the surface, and the dream of finding life there dimmed considerably, shifting focus to other aspects of planetary science. Cut to the early 2000s, a new era of Mars exploration dawning with renewed vigor. Enter the rovers, Spirit and Opportunity, a pair of twin trailblazers that landed successfully in 2004, defying the odds and capturing the imagination of a new generation. These solar-powered wanderers, designed for durability in harsh conditions, weren't explicitly hunting for life directly, but were instead tasked with mapping out evidence of a wetter Mars from its ancient past. Opportunity's high-powered microscope imaged peculiar hematite blueberries, small spherules that formed in acidic waters, hinting at groundwater activity. Spirit, on the other hand, unearthed compelling evidence of ancient hot springs in the Gusev crater region, places where hydrothermal activity could have supported life. Then, in 2012, the larger and more advanced Curiosity rover joins the fray, drilling deep into the layered beauties of Gale Crater to uncover secrets buried in the strata. By 2018, it had detected organic molecules preserved in 3.5 billion-year-old mudstones. Relatively simple compounds like methane and theophanies, but organics nonetheless that sparked intrigue. And in March 2025, curiosity elevated the stakes even further by sniffing out the largest carbon chains discovered to date: decane, undecane, and dodecane, chains 10 to 12 atoms long, strongly hinting at a level of prebiotic complexity previously unsuspected on Mars. This suggests that chemistry on Mars advanced toward life's building blocks far more than we ever thought possible, says Daniel Glavin of NASA's Goddard Space Flight Center. Yet, despite these finds, there was no smoking gun for life itself. Organics, after all, can form through abiotic processes, such as cosmic rays bombarding CO2 in the atmosphere, or hydrothermal vents cooking minerals in the crust without any biological intervention. These groundbreaking missions collectively painted a vivid portrait of Mars as Earth's long-lost twin sibling, wet and potentially habitable for at least its first billion years, boasting vast oceans, intricate deltas, and atmospheres dense enough to generate powerful storms and weather patterns. Life on Earth itself sparked into existence around that same time frame, emerging in similar shallow, watery environments teeming with chemical potential. So why not on Mars as well? Curiosity's data confirmed habitability beyond doubt. pH-neutral waters, energy gradients from redox reactions, and all the necessary ingredients were present, but actual fossils or direct evidence, they remained frustratingly elusive, hidden perhaps deeper in the regolith or eroded away by time. Until that is, the arrival of Perseverance shifted the paradigm once more. Launched amid the global challenges of July 2020 during a pandemic that gripped the world, Perseverance made its dramatic touchdown in Jezero Crater on February 18, 2021, marking a new chapter in robotic exploration. Its primary mandate was clear and ambitious: collect up to 43 samples for eventual return to Earth, with a sharp focus on prioritizing potential biosignatures that could indicate past life. By October 2025, this indefatigable rover has traversed over 32 kilometers of rugged Martian terrain, cached 33 tubes filled with precious samples, and abraded dozens of rocks for the detailed in situ analysis right there on the surface. Chayava Falls isn't just another routine stop along its path. It's the jackpot in what feels like a cosmic lottery, a find that stands out amid thousands of observations. The patterns observed on its surface align remarkably well with Earth's own microbial mats. Think of the layered stromatolites in the shallow waters of Western Australia, or the colorful bacterial blooms thriving in Yellowstone's geothermal hotpots. But Mars, with its unforgiving environment and history of misleading clues, demands more than superficial similarities. And so, the mission team waited patiently, analyzing data with meticulous care. From the initial discovery in July 2024 through to the formal announcement in September 2025, Sapphire Canyon became nothing short of a global obsession among scientists and space enthusiasts alike. Massive data packets, terabytes upon terabytes of high-resolution spectra, detailed elemental maps, and complex computer simulations flowed continuously to laboratories scattered worldwide, from Pasadena to Paris. The peer review process for the resulting paper in Nature wasn't a mere rubber stamp approval. It was a rigorous crucible designed to test every hypothesis and conclusion. "We threw everything we had at it," says Joel Hurwitz, the lead author and a dedicated Perseverance scientist at Stony Brook University. Chemical models, precise isotopic ratios, comparative geology from Earth analogs. We explored it all. Could geology alone explain this without invoking biology? We simply couldn't find a convincing way that held up under scrutiny. Here's where the true magic of the discovery reveals itself. All three fundamental pillars of life as we know it converge dramatically in one compact, fist-sized core sample. First, there's the undeniable evidence of liquid water, manifested in the mudstone's fine, delicate laminations, which could only have formed in calm, subaqueous depths where sediments settled slowly over time. Second, the organics. Sherlock's instruments detected both aromatic and aliphatic compounds precisely concentrated at the dark spots. Carbon skeletons that on Earth would strongly suggest biological origins. Third, the energy source. Those distinctive vivianite and grayite rings point directly to redox reactions, electrons shuttling back and forth between iron and sulfur ions, a favored metabolic pathway for microbes to generate ATP, the universal energy currency of life. Horowitz aptly likens the whole assemblage to stumbling upon an abandoned campsite in the wilderness. You see a fire ring made of charred stones, scattered scattered bones left over from a meal, and fresh footprints imprinted in the ash. No one's there now, but damn, it's clear that someone was. And recently, on Earth, these exact features form when bacteria engage in anaerobic respiration, oxidizing iron while reducing sulfate compounds, excreting secondary minerals as byproducts of their life processes. The spots themselves, they appear to be ancient waste dumps from a microbial feast that took place 3.7 billion years ago, back when Jezrero's lake was likely teeming with invisible life forms going about their business. But science at its core is an exercise in humility and caution. The team wisely invoked NASA's Confidence of Life Detection (CoLD) scale, a structured 7-rung ladder ranging from dubious signal at the bottom to ironclad proof at the top. Sapphire Canyon's status, it's likely perched solidly at a 4 or 5, highly compelling but not yet fully conclusive without further verification. Why the hesitation? Because Mars has proven itself time and again to be a master of mimicry, fooling even the best instruments with abiotic tricks. Extraordinary claims, as the legendary Carl Sagan so memorably etched into our collective scientific psyche, demand extraordinary evidence to back them up. So let's methodically dissect the rival explanations one by one. Could this entire phenomenon be nothing more than abiotic sleight of hand, a clever illusion crafted by non-living processes? Hypothesis 1 revolves around high-temperature geology as the culprit. Imagine powerful hydrothermal vents superheating the surrounding mud, driving rapid mineral precipitation without any need for microbial involvement. Vivianite and greyjet can indeed form under such conditions, but only if temperatures soared above 100 degrees Celsius for extended periods. Yet the rock's pristine olivine grains, a common magnesium iron silicate mineral, tell a different story. They survive intact only in environments below 50 degrees Celsius, as higher heat would cause them to melt or alter irreversibly. There are no scorch marks or thermal alteration signatures anywhere in the sample, so no dice for this idea. It simply doesn't hold water. Hypothesis 2 proposes acidic leaching as the mechanism. Picture sulfuric waters slowly percolating through the rock over geological ages, etching out patterns and depositing sulfide minerals in their wake. This seems plausible at first glance for the sulfur-rich spots observed, but the veins in the rock scream of neutral pH conditions. Once again, olivine comes into play, acting as acid's kryptonite, remaining intact and essentially mocking the very idea of widespread acidity. There's no evidence of widespread corrosion or acid scars anywhere else in the Jezero region, further undermining this explanation. Hypothesis 3 suggests catalytic chemistry at work. In this scenario, the organic molecules self-react under the influence of some mystery catalyst substance, birthing the observed minerals without any requirement for life to intervene. Laboratories on Earth can replicate similar processes at elevated temperatures, but in the chilly depositional environment of ancient Mars, it's highly unlikely. Computer models consistently show reaction rates that are far too sluggish to produce these features without some form of biological kickstart to accelerate things. Each of these alternatives falls short in its own way, like mismatched puzzle pieces forced from entirely different boxes. We've systematically ruled out the prosaic explanations, says Katie Stack Morgan, Perseverance's dedicated project scientist at JPL. What's left standing is something truly profound, the strong possibility of ancient life. The landmark paper in Nature, officially published on September 10, 2025, seals this assessment as a potential biosignature. Undoubtedly the rover's strongest and most convincing candidate to date. This isn't mere hype designed to grab headlines. It's the result of rigorous, peer-reviewed science, and it builds seamlessly on 2025's other remarkable Mars marvels. Curiosity's detection of long-chain organics back in March suggests that prebiotic soup simmered on the planet for far longer than previously imagined, providing ample time for complexity to emerge. In May, it finally cracked the long-standing missing carbonates riddle by identifying siderite deposits in Gale Crater, ironclad proof that much of Mars's ancient CO2 was locked away into rocks rather than escaping into space, elegantly explaining the planet's dramatic atmospheric fade-out over billions of years. Jezero's relative youth, its sediments dated to only 3.2 to 3.8 billion years old, implies that habitability conditions lingered on Mars for extended periods, buying precious time for life to bloom and evolve, transitioning smoothly from the realm of data and and analysis to the broader dreams it inspires. If microbes once slurped sulfur compounds in Jezero's shallow waters, what new worlds of possibility open up before us? But true proof demands more than remote sensing. It requires physical touch. Enter the mission that's as audacious in scope as it is precarious in execution. Perseverance, for all its technological wizardry, simply can't crack this particular nut alone from millions of kilometers away. Its onboard tools are nothing short of genius. Lasers precisely zapping targets, X-rays probing elemental secrets. But Earth's state-of-the-art laboratories wield advanced instruments like high-resolution electron microscopes, sensitive mass spectrometers, and precise isotope sorters that dwarf anything a rover can carry. To climb the CoLD scales ladder all the way to level 7, requiring multiple independent verifications from diverse techniques, we absolutely need those samples back in hand on our home planet. Cue the Mars Sample Return, MSR program, NASA's ambitious crown jewel in planetary science, though it's also been a source of occasional headaches due to logistical challenges. As we draw this narrative to a close, take a moment to reflect deeply. Chayava Falls isn't just an inert rock on a faraway world. It's an open invitation extended to all of us. An invitation to wonder at the mysteries of the universe, to connect with one another through shared curiosity, and to evolve as thinkers and dreamers. What stirs within you after this journey? Drop a comment below. Is life on Mars a potential hoax or the horizon of a new era? Hit like if this story ignited a spark of wonder in your mind. Subscribe now for the sequel, diving into MSR's unfolding saga, exoplanet hunts, and beyond. Together we chase the stars and uncover their secrets.